Today we're going to cover one of the market structure, perfect competition. Perfect competition is one of the more extreme extreme market structure, or it is on one end of the spectrum of market structure. With perfect competitions, there are many sellers. There's a large number of sellers, and these sellers sell very similar products, if not identical. Okay? So the products sold by all the firms in the industry are identical. And it is very easy to enter and exit this industry. Well, this should be intuitive. The fact that there are so many sellers indicates that it must be very easy to get into this business, get into this market. Buyers and sellers have perfect information in the sense that buyers know what prices are being charged in the market. Sellers knows what all other sellers are charging in this market, and sellers don't know more than buyers and vice versa. Because there are so many sellers and each seller sells very similar products, if not identical. So that means each seller is small relative to the entire market. And because they sell very similar products, so that means their customers can easily switch from one to another. So that leaves individual, perfectly competitors with a very elastic demand. In fact, perfectly competitive firms theoretically have a perfectly elastic demand. Okay, so that means whenever customers do not like the price, they can easily switch to other customers. Okay, very flexible. So and each perfectly competitive firm is a price taker because it's small and it sells identical products to its competitors, so that leaves no room for pricing decision. So the perfect competitor firm is a price taker in the sense that the price is actually taken from the market. It is determined by the market supply and demand. So all firms, all buyers in the market together. So on the left-hand side, we have a perfectly competitive market. So the usual demand curve and the supply curve. And you can see that the market price is at $1 and the total market quantity is 20 billions of bushels. Okay? And on the right-hand side, we have an individual perfectly competitive firm which is faced with a perfectly elastic demand curve. As we have learned several weeks ago, a perfectly elastic demand curve is represented by a horizontal demand curve. Okay? So the price is at $1. So each individual perfectly competitive firm takes this price as given. Okay? So it is perfectly elastic in the sense that if any individual firm tries to raise the price teeny little bit, above $1, $1.01, for example, the whole demand curve is gone. There will be zero quantity demanded. Nobody will buy from this individual perfectly competitive firm. So how does a perfectly competitive firm decide how much to produce? Well, it is no different from other types of firms. Okay? As we have previously learned, a firm maximizes its profit, okay? Or sometimes minimizes its losses, okay, by producing a quantity where the marginal revenue is equal to marginal cost. Okay? So we're repeating what we have learned in profit maximization. When marginal revenue is greater than marginal cost, so meaning if the cost of producing one more unit is less than the revenue it generates, then a profit is available for the firm that increases production by 1 unit. Okay, so whenever marginal revenue is greater than marginal cost, this company will continue to produce. If the cost of producing one more unit is more than the revenue it generates, then increasing production reduces profit. So whenever marginal revenue is less than marginal cost, so the company will cut down on its production. So ideally, a firm will stop at a point where the marginal revenue is equal to marginal cost. Okay? Sometimes, because we're dealing with discrete number instead of continuous numbers, we probably don't have this ideal situation. If that's the case, we stop at the last unit of output that gives us this condition, where the marginal revenue is greater than marginal cost. But ideally, we'll try to achieve this. Okay? So let's look at an example. So this is obviously a perfectly competitive firm. How do we tell? Well, you look at the first two columns. As the quantity demanded increases, the price stays the same. So we have a horizontal demand curve, which is a perfectly competitive firm. Okay, so previously, we learned that profit maximization's condition is where the marginal revenue is equal to marginal cost. So let's look at it closely. Can we find it? So here, right? So this is when the marginal revenue is equal to marginal cost. And the corresponding quantity of output is 9 units. So this company will be doing its best, will be optimal, or will maximize profit or minimize loss by producing 9 units. Okay, so let's look at diagram. Okay, so the demand curve, okay, at $1, okay, so that's what we have seen from the table. And this is the marginal cost curve, okay, plotted using the data, okay, from the table. So where the marginal well, we have to take a step back because the demand curve is elastic, or the price is constant, regardless of the quantity, we have a very peculiar result for a perfectly competitive firm. So each additional unit derives a revenue that is the same as the price. This is not the case for other types of firms. This is only the case for a perfectly competitive firm. P equal to marginal revenue. Okay, price equal to marginal revenue. So we can make use of this peculiar condition from time to time. Okay, so now let's go back. So to find the profit maximization condition, so we find where the marginal cost crosses the marginal revenue curve. So in this case, it's a perfectly competitive firm, so the marginal revenue curve is exactly the same as the demand curve. Okay, so this point here, this cross here, this intersection here, gives us the optimal quantity of output, or so-called profit maximizing output level. 9 units. So the next thing we want to see is, well, whether this is a profit or a loss. So one at a time. So when you look at the big box here, the big rectangle here, okay? So the vertical distance here is a price, okay? And the horizontal distance here is a quantity produced by this firm. So price multiplied by quantity. So this big rectangle here is the so-called total revenue. Okay, is total revenue. Okay, P times Q. And then when we look at it closely, okay, we have an average total cost curve, okay, which will give us the per unit cost. So at 9 units, the per unit cost, the average total cost is 87 cents. So per unit cost, the vertical distance here, per unit cost, multiplied by the quantity sold, that will give us the total cost. So the smaller rectangle here will give us the total cost. Okay? So the big rectangle minus the smallest rectangle. So the difference is just the shaded area here, A, B, C, D. This shaded area here, the rectangle, the shaded rectangle, that's the profit. So it is a profit because the price, which is $1, obviously is greater than the average total cost, 87 cents. Okay, so for each unit that it sells, the price more than covers the cost. Okay, so we have a profit here. But that is not to be taken for granted. Not all companies is profitable. So now let's look at this. This is the same company, but this time the market situation has changed. So the demand for this product or the service has come down. So as a result, this company is faced with a lower price. Instead of $1, now it's 70 cents. Okay, 70 cents. Okay, so let's find the profit maximizing condition or the loss minimizing condition, okay, the optimal condition. So, well, can you find it? Can you find it? Can you find it? So yeah, we got it here. So marginal revenue equal to marginal cost. And so the corresponding quantity is 70 cents. Okay, 70 cents. This is a slightly complicated case. We probably won't have that in the exam, but some of you may notice that we have another condition here. This is also this is also a quantity where the marginal revenue is equal to marginal cost. But later on, we'll find that this is the optimal quantity. 6 is the optimal quantity, because when you compare the loss, you'll find that this will give us a smaller loss. Okay, so when we are not maximizing profit, when we're not able to have a profit, our goal here is to minimize a loss. Okay, so it's the same diagram. Okay, it's the same diagram. So previously the price is at $1, but now we have a new demand curve. So the price now is at 70 cents. Okay, everything else stays the same. We have the same marginal cost curve. We have the same average total cost curve. So first, let's find the profit maximization condition or the loss minimization condition. So this is when the price, okay, or the marginal revenue is equal to the marginal cost. For a perfectly competitive firm, it is essentially the same to say that the price is equal to the marginal cost at the optimal condition. Okay, but in general, we want to know that it is the marginal revenue equal to marginal cost. So it's a cross here, F. Okay, at 6 units. So is it a loss or is it a profit? Well, we look at the average total cost at 6 units. the cost to produce each unit is 87 cents. That's the average total cost. Okay, so you can see that the average total cost is greater than the price. Each unit itself, this company is experiencing a loss. Okay, so this smaller rectangle here, the price multiplied by the quantity, that will give us a total revenue. Okay, total revenue. And the bigger rectangle here, that's the average total cost, okay, 87 cents, multiplied by the quantity of output, 6. So that will give us the total cost. You can see that the total cost is greater than the total revenue. So we have a loss. We have a loss. So this shaded area here is a loss. If you want to calculate how much is it, is 17 cents multiplied by 6. Okay, 17 cents, 13 cents, okay, 13, oh no, sorry, my bad, it's 17 cents. 17 cents multiplied by 6. Okay,